Hello everyone, this is our session 2 on pairs of straight lines. We're beginning with the first exercise now. Okay, so the first exercise, exercise 4.1, question 1. Question 1 says that find the combined equations of the following pairs of lines. The first one is simple. I'm doing the second one for you. The second one says the two lines are x plus 2y minus 1 equal to 0 and x minus 3y plus 2 equal to 0. So you have to find the combined equation of these two lines. What do we do? So we can, only for this sum, I'll show you how you can write it. We say that if the first line is u equal to 0 and the second line is v equal to 0, then combined equation is given by uv equal to 0, right? So let us say that this is your first equation, which is u, okay, and this is your second equation, which is v. So uv equal to 0, uv equal to 0 will be what? Multiplying of x plus 2y minus 1 into x minus 3y plus 2 equal to 0. Multiply each term, so we get x square minus 3xy plus 2x plus 2xy minus 6y square into plus 2 to the 4y minus x plus 3y minus 2 equal to 0. Okay, take the terms that are same together. So we have x square, we don't have any other x square, so it will be x square. Minus 3xy plus 2xy is minus xy, no other xy term, so minus xy. Okay, then plus 2x minus x, so plus x. Then plus minus 6y square, no other y square terms, so minus 6y square. Then we have plus 4y plus 3y is plus 7y minus 2. Only one constant term we have here, minus 2, okay, equal to 0. So you can just rearrange the terms here as x square minus xy plus 6y square, okay, plus x plus 7y minus 2 equal to 0. You're just getting all the degree terms, that is square, second degree, second degree, second degree, then first degree, and then no degree. Okay, this is getting them together. That is your second sum. Let's move on to the third one now. Okay, the third says find the combined equation of lines passing through 2, 3 and parallel to the coordinate axis. Okay, so given would be passing through 2, 3 and parallel to axis. Okay, now equations of the axis are x equal to 0 is equation of y-axis and y equal to 0 is equation of x-axis. Okay, now therefore the equations of the line passing through 2, 3 and are parallel to the axis. So if any line is parallel to the x-axis, okay, so its equation will be y equal to a constant term. Now what is that constant? Since that line is passing through 2, 3, so that equation will be y equal to 3, and a line passing through 2, 3 and parallel to the y-axis will be of the form x equal to constant. What is that constant? 2. Okay, so where is this 3 and 2 coming from? It's coming from, one second, it's coming from here. If you can observe, y equal to constant and 2 equal to constant. Okay, y equal to constant is the line parallel to the x-axis, x equal to constant is a line parallel to the y-axis. So these are the two equations, y equal to 3 and x equal to 2. How do you find the combined equation now? So those equations will be y minus 3 is equal to 0 and x minus 2 is equal to 0. These are our two lines. Okay, first one and second one. How would you find the combined equation? So we have x minus 2 multiplied by y minus 3 equal to 0, which will be xy minus 3x minus 2y plus 6 equal to 0. Okay, this is already in the degree form. You don't need to change anything. This is your final answer. Okay, let's move to the next one now. That is the fourth one. Okay, so the fourth sum says that find the equations, combined equation of the lines passing through 2 comma 3 and perpendicular to the lines 3x plus 2y minus 1 equal to 0. So we can say that two lines are given. First one, 3x plus 2y, 3x plus 2y minus 1 equal to 0 and x minus 3y plus 2 equal to 0. Okay, these are the two equations that they are given. They have also said that the lines are passing through 2 comma 3 and perpendicular to the lines. Okay, so lines are passing through 2 comma 3 and are perpendicular to the above lines. Okay, now we need to find out these two lines and then we can get their combined equation. Okay, so how will we find out? So let us consider the first equation. Okay, consider 3x plus 2y minus 1 equal to 0. Let's find its slope. I will write it in the form of y equal to mx plus c, which will be 2y is equal to minus 3x plus 1. Y is equal to minus 3 upon 2 x plus 1 upon 2. Okay, so what is the slope of this line? M is equal to minus 3 upon 2. Okay, we can call this as M1. Okay, now the next line, second line. Rather, let's start from here only. Now, if a line is perpendicular to this given line, this first line that we have, if a line is perpendicular, then what will be its slope? So, it's the reciprocal of the slope of this line, negative reciprocal. Therefore, we'll call it as m1 dash is equal to minus 1 upon m1. Slope of line perpendicular to first given line. Clear? Okay. So what will be the slope? It will be minus 3 upon 2. So 1 upon minus 3 upon 2, which is equal to minus 2 upon minus 3. So that is 2 upon 3, m1 dash. Okay, so one slope I have. Let us find out the next one. So consider the second equation. What is the second equation? X minus 3y plus 2 equal to 0. X minus 3y plus 2 equal to 0. So we can say minus 3y is equal to minus x minus 2. Y is equal to minus 1 upon minus 3x minus 2 upon minus 3. Okay, so what is the slope of this line now? M2 is equal to minus 1 upon minus 3, that is 1 upon 3. Okay, so what will be the slope of line perpendicular to this? M2 dash is equal to minus 1 upon M2. Okay, slope of line perpendicular to second line. Okay, which will be equal to minus 1 upon what is M2? It is 1 upon 3. So 1 upon 3, which is equal to minus 3 m2 dash. Okay, so we have m2 dash with us. Now, what will be the equation of these perpendicular lines? So we'll write it in the form of y minus y1 is equal to m into x minus x1. Okay, equation of line. This is general form. We're going to use it for our two slopes that we have. M2 dash, this should be. Yeah. Now, let us write the equation of the first perpendicular line. So therefore, equation of first perpendicular line is what it will be. Y minus y1 is equal to m. What is this m1 rather? I would write that. So m1 dash x minus x1. Okay, y minus y1 is equal to m1 dash. What is m1 dash? Here, 2 upon 3. So let us put 2 upon 3 here and x minus x1. Now, point 2 comma 3 lies on it. When a point lies on a line, what do we say? It satisfies the equation of the line. Therefore, it satisfies the equation. We'll call this as 4, so the equation 4. Y minus 3 is equal to 2 upon 3 x minus 2. Okay, you can solve this. 3y minus 9 is equal to 2x minus 4. Okay, which will be 3y minus 2x minus 9 plus 4 is minus 5 equal to 0. Okay, this is your first equation, but we cannot put it as 1. So we just call it A, capital A. Okay, so that is your first equation. Similarly, you can find out the second equation. 2x minus okay, this is your first equation. For the second equation, again same rule we'll use. So equation of second line will be y minus y1 is equal to m2 dash into x minus x1. If y minus y1 is equal to, what is m2 dash? It is minus 3. So let's put minus 3 here. X minus x1, which is the point that lies on it. 2 comma 3 lies on it. Hence satisfies the equation. Okay. So y minus 3 is equal to minus 3 x minus 2, which will be y minus 3 is equal to minus 3x plus 6. We have 3x minus y minus 3 minus 6 is minus 9 equal to 0. This is your B equation. And now we'll find the last part, that is combined equation. Therefore, combined equation is equal to A into B. Okay, so what is A? 3y minus 2x minus 5. So 3y minus 2x minus 5 bracket multiplied by 3x minus y minus 9. Okay, equal to 0. Let's multiply this. So we'll get 9xy minus 3y square minus 27y minus 6xy minus 2xy minus 2 minus 7 plus 2xy plus 18x minus 15x 5y 45 equal to 0. Now let us check our x square term. Okay, one x square term is missing. We have not put it. Minus 2x into 3x is what we have not added. So let's just add that here. Let me check once. 9xy minus 3y square minus 27y minus into plus minus 6x square to minus plus, okay, this should have been minus 6x square. Okay, yes, equal to 0. Okay, 45. Okay, just rearrange the terms and add and subtract, so that will give you a final answer. So the final answer is, since minus 6x square, then the xy term, so 9xy plus 2xy is 9, 10, 11xy minus 3y square. Then the x terms, minus 15 plus 18 is plus 3x plus 5y minus 27 minus 22y plus 45 equal to 0. This is your final answer. If you want, you can multiply the entire equation by minus, so that 6x squared, that is your first term, would not be negative. Okay. 1 second. Okay, so our second equation will be 3x plus y minus 9 equal to 0. Now let us multiply the two equations. So we'll have combined equation as is equal to a multiplied by b. Okay, what is a? Is our first equation of the line, 3y minus 2x minus 5. Now write the x term first. So minus 2x plus 3y minus 5 minus 5, okay, multiplied by b. What is b? 3x plus y minus 9 equal to 0. Let's multiply. So we'll have 6x square minus 2xy minus plus 2 9s are 18x plus 9xy into plus, that is 3y square, 27y minus 15x minus 5y plus 45 equal to 0. Okay, so your final answer would be 6x minus 6x square minus 2xy plus 9xy is 7xy. Okay, plus 7xy plus 3y square minus 15x plus 18x is plus 3x minus 5y minus 27y is minus 32y plus 45 equal to 0. If you want, you can multiply the entire equation with a minus sign. So you would get 6x square minus 7xy minus 3y square minus 3x plus 32y minus 45 equal to 0. Okay, that's the combined equation of these two lines. Okay, let's move to the next one now. Yes, so now in the second question, question 2, we have to find the separate equations from the combined equations given. I'm doing the fifth one for you. So they've given the equation as 3x square minus 2 root 3 xy minus 3y square equal to 0. Basically, you have to factorize the middle term. Okay, so how would we do this now? It's just the same as you factorize quadratics. The two factors that we are going to find out is 3x square minus 3 root 3xy plus root 3xy minus 3y square equal to 0. So if you observe, the coefficient of x square and y square has to be multiplied, so you get minus 9, and then you find its factors. So this is 3 root 3 into root 3. That is 3 into 3, 9. Okay, now the sign, you want a negative in the center, so that will be minus and plus. Minus into plus is minus. Minus 3 root 3 plus root 3 is minus 2 root 3. Okay, taking 3x common, I'll get x minus root 3y, okay, plus y common, or you can say root 3y common, sorry, root 3y common, and you get x minus root 3y equal to 0. So we have 3x plus root 3y, okay, and we have x minus root 3y as the two brackets. Separate them and they are the equations of your two lines. So therefore, the two equations are, what will they be? 3x plus root 3 equal to 0 and x minus root 3y equal to 0. These are the two equations. Simple. So first few sums, first almost 4 to 5 sums, you have to only factorize the equation, get the factors, those are the equations of your line. Okay, I'm moving on to the sixth one now. That is a different way of factorizing. We've done this also. X square minus 2 cosec alpha xy plus y square equal to 0. So what do we have to do here? Factorize again, okay, but now we know quadratic factorization, so what we'll do is we'll convert it into a quadratic. Okay, so I'm writing this as y square minus 2 cosec alpha xy plus x square equal to 0, and I divide it throughout by x square. Divide throughout by x square. So what will I get? Y square upon x square minus 2 cosec alpha. Now when I divide this by x square, I'm going to get y upon x, okay, plus 1 equal to 0. Now what does this look like? Is it some kind of a quadratic? How to understand this? So I'll say let y by x equal to m. So I'm going to get, sorry, m square minus 2 cosec alpha m plus 1 equal to 0. Now, this is a quadratic in m and it has two roots, m1 and m2. Okay, how do you write these roots now? If you remember, I'm just writing this equation here, m square minus 2 cosec alpha m plus 1 equal to 0, comparing with ax square plus bx plus c equal to 0. Okay, so this is a quadratic in x, this is a quadratic in m. A is equal to 1, b is equal to minus 2 cosec alpha, okay, and c is equal to 1. Now roots of this quadratic ax square plus bx plus c is given by what? X is equal to plus minus b, sorry, minus b plus minus under root of b square minus 4ac upon 2a. Okay, this is how the roots are given. So what will be m1, m1 comma m2 is equal to minus b. What is minus b? Minus 2 cosec alpha. So plus 2 cosec alpha, okay, 1 second, let me check the sign. Oh, so sorry, the sum has a positive sign here. 1 second, the sum itself is positive, plus 2 cosec alpha. So we'll have a plus here. This will also be plus. Yes, sorry, extremely sorry. So this will be plus again. Okay, now let us substitute it to get the two roots. So what are the two roots? Minus b, so minus 2 cosec alpha plus minus under root of b square. So that is 2 cosec alpha square. Okay, minus 4, a and c is 1. Okay, divided by 2, what is a? 1. Okay, so what are the roots that we are getting? We get minus 2 cosec alpha plus minus under root of, we get 4 cosec square alpha minus 4. Okay, divided by 2. We have minus 2 cosec alpha. We can have 4 outside, so we get plus minus 2 root of cosec square minus alpha. Sorry, minus 1. What is cosec square minus 1? It is cot alpha, right? So we'll have 2 common here. Rather, we'll write this as 2 common minus cosec alpha plus minus root of cosec square minus 1 is root of cot square, that is cot alpha. Okay, and this 2 here which cancels out. So m1 comma m2 is equal to these two roots. Okay, therefore we can write them separately as m1 is equal to minus cosec alpha plus cot alpha, and m2 is equal to minus cosec alpha minus cot alpha. Okay, now m1 is resubstitution. What was m1, m2? Let's go back and check what was m. M was y by x. So m1, m2 are the roots, so that will be y by x. Therefore y by x is equal to minus cosec alpha plus cot alpha, and here again y by x is equal to minus cosec alpha minus cot alpha. Okay, so you can just put the x term there and you get minus cosec alpha plus cot alpha multiplied by x, and here y is equal to minus cosec alpha minus cot alpha multiplied by x. Okay, so these are your two equations, y equal to in the form of y and x. Okay, you can get it on one side, equate them to 0. Those would be your two equations. Clear? So we've completed 2 questions of exercise 4.1. In the next session, we'll do the remaining sums. If you have any doubts, do let me know. Thank you.